Okay, so this is Jacob's chapter 8, lesson 7. This lesson is about exponential functions. We can have functions that increase exponentially or that decrease exponentially. The form for an exponential function is y equals a times b to the x. Now you've got to be very careful to realize that this x exponent only applies to the b. Remember PEMDAS, our order of operations rules, parentheses and then exponents and then multiplication division. Now I just wrote the parentheses up here, but once we have an exponent on a number, that exponent is tied to that number. So y equals a times b to the x. We do b to the x first and then we multiply it by the a. So this is the form for an exponential function when both a and b are positive. That means they cannot be 0. 0 is not a positive number. Okay, so let's start with our first example. We're going to look at number 4, and we're going to start with part A. The instructions for number 4 say, write each of the following in the form of a times b to the c. So we want to write everything in exponential form. So for part A, what they give us is 8 times 10 times 10 times 10. Well, when we try to rewrite it in this form, that's going to be 8 times 10 cubed. We have 10 multiplied by itself 3 times, so that's our 10 cubed. And then our number that we have just once is the 8. So 8 times 10 cubed. Let's hop down to part C, which is 4 times 11. You can see pretty quickly here that our 4 is squared, and that's multiplied by 11, but that is not in this form. We have to have our single number first, and then our number that's raised to a power. So when it asks for a particular form, make sure that you put your answer in that form. The last one we're going to do from number 4 is part D. Part D is 6 over 10 times 10 times 10 times 10. Okay, so we can see that this is 6 over 10 to the 4th, but that is not in the format that it asks for. We want a times b to the c. Well, our a is 6, our b is 10, and remember that 1 over x is equal to x to the negative 1. Since we have 6 over 10 to the 4th, we can change that to 6 times 10 to the negative 4. 10 to the negative 4 is the same as 1 over 10 to the 4th. So that is how you work number 4, which is just like number 10 in our homework. Now we're going to go to a new page. We're going to look at number 5. Number 5 is just like number 11 in the homework. It says write in decimal form. So we're going to do just a couple of these. Look at part C is 9 times 2 to the 0. You can see it's in the form that we've learned for an exponential function. 2 to the 0 is just 1. So this is 9 times 1, and 9 times 1 is just 9. That's our final answer. Part D, we have 36 times 3 to the negative 2. Well, 3 to the negative 2 is 1 over 3 squared, so we can rewrite this as 36 divided by 3 squared. Well, and 3 squared, that's just 9. What is 36 divided by 9? That is 4. So that's our answer for part D. Part E is 8 times 10, oh no, sorry. It is 8 times 1 to the negative 10. Well, 1 to the negative 10, 1 to any power actually, is just 1. So this is the same as 8 to 1, 8 times 1, which is just 8. So again, this was number 5, which is just like number 11 in the homework. Okay, moving on, we're going to do number 6. Number 6 says this exercise is about the exponential function y equals 4 to the x. Copy and complete the following table for this function. So I'm going to make this a vertical table. So that looks really horrible. Let me get rid of that. Let's just draw a nice straight line here. Okay, so now we're going to put in our values for x, which are 0, 1, 2, 3, and 4. To fill in this table, we need to replace our x with these numbers that we have in the data table. So our y is 4 to the x. So we're going to start off with 0. So our y is 4 to the 0. That's just 1. When x equals 1, our y is 4 to the 1. That's 4. When x equals 2, we have 4 squared, which is 16. When x is 3, we have 4 cubed, which is 64. And when x is 4, we have 4 to the 4th power, which is 256. Okay, that was part A. Part B asks, what happens to y if x is increased by 1? Well, look at this here. X is increased by 1. Our y is increased by 3. When our x is increased by 1 again, our y is increased by 12. Okay, so we can't use adding on our y. What we can use is multiplying. When our x goes up by 1 from 0 to 1, our y is multiplied by 4. When our x goes up another 1 from 1 to 2, our y is multiplied by 4. So that is what we have to put in for our answer for part B. Y is multiplied, I'm just going to write mult by 4. Okay, part C, I'm sorry, this is part D. No, this is part B. Our part C asks, what happens when our x is increased by 2? Well, let me get rid of what I've already got here real quick. Oops, that is not the one I wanted. I wanted the select tool. Sorry, grabbed the wrong tool. Let's get rid of that, and we will get rid of this. Okay, and get rid of this part here. Okay, fine. I'll have to rewrite my 6. Okay, now we want to have our x increase by 2. When our x increases by 2, our y is multiplied by 6. When our x increases by 2 here, from 2 to 4, our y, did I say 6? 16. Our y is multiplied by 16. So when we add 2 to our x, we multiply our y by 16. So our y is multiplied by 16. Part D asks the same thing for when x is increased by 3. You can see when our x is increased by 3 here, our y is multiplied by 64. So y mult by 64. And this is number 6, which is just like number 12 in your homework. Okay, so let's move on now to number 7. Number 7 is just like number 13 in your homework. And I'm going to do this in 2 parts because what we're going to do for number 7 is we have 3 different functions which we are going to make tables of values for and graph. So I'm going to do these one at a time. Parts A and D are for the function y equals 3x. So first we're going to make a table of values for that. So we're going to make an XY chart, and I'm going to draw my straight line here. Whoop, there we go. So we're going to make an XY chart, and we want our x to equal -2, -1, 0, 1, and 2. Okay, so when our x is -2, 3 times -2 is -6. 3 times -1 is -3 because we're using this function up here. 3 times 0 is 0, 3 times 1 is 3, and 3 times 2 is 6. Okay, now what we're going to do is graph this, and this is going to be just the best I can do. At least I have a nice line drawing tool. So I'm going to draw my axes, and now I've got to put on my scale. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. Okay, so here we have our x-axis and our y-axis. When our x is -2, our y is -6. When our x is -1, our y is -3. When our x is 0, our y is 0. When our x is 1, our y is 3. And when our x is 2, our y is 6. So then if I've gotten this aligned nicely, I should be able to draw a straight line through my points. Doesn't exactly match up because I just had to eyeball where these things went. But what you will end up with is a straight line graph. Okay, So now let's look at the next function. So this was parts A and D. A is doing the table of values, D is drawing the graph. Now we're going to look at the second function they give us. 7b is y equals x cubed. So first we'll do a table of values and then we'll draw a graph. The graph is part E. So let's draw my table of values. Okay, so we have our x and our y, and again our x is -2, -1, 0, 1, and 2. When our x is -2, -2 to the third power is -8. This is an odd power, that means it keeps the sign. -1 to the third power is -1, because -1 to any power is -1. Well, actually, I take that back. -1 to an even power is a +1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. So now we will draw a graph. So here we go. And again, our x values are just going to be -1, -2, +1, +2. And now we draw in our y's. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when our x is -2, our y is -8. When our x is -1, our y is -1. When our x is 0, our y is 0. When our x is 1, our y is 1. And when our x is 2, our y is 8. Clearly, you can see this is not a straight line. Instead, what we're going to have, and I will do my best to make a graph that looks decent here, which is harder to do on the computer. Okay, I missed my dot. We'll have a graph that looks something like that. So that is what x cubed looks like. Now for the last part, 7c and 7f. For 7c, we're going to do the function y equals 3 to the x. And again, we're going to go through those same values for x and y. So for x, to get our values of y. So we have our x and our y. Our x is -2, -1, 0, 1, and 2. So 3 to the -2, that is the same as 1 over 3 squared, which is 1/9. 3 to the -1, that is the same as 1 over 3, which is 1/3. 3 to the 0, that is 1. Remember, anything to the 0th power is 1. 3 to the first power is 3. 3 to the second power is 9. Okay, you will notice we do not have any negative values for our y, which means we can make a simpler graph here. I'm going to make my y-axis really short in the negative direction because we don't have any negative values. So here's -1, -2, +1, +2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm trying to make these evenly spaced, but not succeeding very well. When our x is -2, our y is 1/9. So that's going to be like just right above the x-axis. When our x is -1, our y is 1/3. So we're going to go up just a little bit more. X is 0, y is 1. X is 1, our y is 3. X is 2, our y is 9. So you can see we're going to have a graph that increases, and I kind of missed my dot again, very quickly in that direction. And in this direction, it's just going to get smaller and smaller and smaller, get closer to 0, but never actually reach it. So this is number 7, which is just like number 13 in the homework. I'm going to have to do a part 2 video that shows you numbers 8 and 9. Just be aware, make sure that you do these graphs on actual graph paper and do each graph on a separate Cartesian coordinate system. Use separate axes for them. Don't try and do them all on the same axes. So for number 13, which is just like this number 7 that I just did, you're going to be doing 3 different table of values, and you're going to do a graph for each one of those. And on the next video, I will cover problems 8 and 9, which are just like numbers 14 and 16.